Hi everyone. In this video I want to talk about good habits in calculations. We're going to be using the speed equation in this video here. We've got some pretty simple questions, but if we can learn the good habits with the simple questions, then that'll help us a lot with more challenging questions down the track. The two other equations that we see here are just different versions of the speed equation. And one of the videos we'll do soon will look at this idea of how you can convert between versions of the speed equation and how you can manipulate equations. Some good habits to consider when you're doing calculations is that you want to read the question carefully, list any values that you've been given, show the equation that you've chosen to use, show all your working, give your answer, and remember to put in the units. Let's look at this first question. Adam walks down the street and he travels 30 meters in 15 seconds. What is his velocity? So we read the question carefully and we try and identify what's the important information for this question. And we see here that he's moving 30 meters in 15 seconds and we need to know his velocity. Velocity is a vector. We write down our givens. So first of all we start with S equals 30 meters and the time equals 15 seconds. Then we have to choose an equation. Now, we want velocity. V is the thing that we are interested in. That's the big question mark. So we look at our choices for equations to use, and the speed equation, the middle one here circled, is probably the best one for us to use. So we're going to choose that one. And so we put in V equals S over T. We show our working, so that equals 30 meters over 15 seconds. We give our answer, which of course is 2, and we don't forget the units, meters per second. Okay, we've listed our givens, so that's looking good. We've shown the equation that we want to use. We've shown our working. We've given our answer. And we haven't forgotten the units. Good habits. Another question. Beth rides her bike 60 meters in 12 seconds. How fast is she going? So the important information in this question as we read it carefully, 60 meters in 12 seconds, how fast is she going? Actually, let's take a step back to question 1. We were asked about the velocity. 2 meters per second needs a direction. The only direction they've given us in the question is that he's going down the street. So we'll put down there, down the street. Let's go back to Beth. Beth rides a bike 60 meters in 12 seconds. How fast is she going? So we've read the question carefully. We list any values that we know. So S equals 60 meters. Time equals 12 seconds. And we want to know how fast is she doing. Now we have to choose an equation. Well, I think we'll go with the speed equation again. V equals S over T. So we declare the equation. We show our working, 60 over 12. We give our answer, 60 divided by 12 is 5. And we don't forget our units, meters per second. So we have listed our givens, shown the equation, shown the working, given the answer, and we haven't forgotten the units. Another example. Candace drives 150 kilometres south. So this is Candace. She's travelling at 100 kilometres an hour. How long does it take her? Now this question seems a little bit different, but still, if we follow the same good habits, we should be okay. So the first good habit, read the question carefully, done that. Second good habit, list your givens. Where is she going? She's going, her distance is 150 kilometres south. Now, they've given this value in kilometres. We'll stick with it for the moment because we notice that the speed is in kilometres per hour. So we'll stay with kilometres for the time being. They've told us that her speed is 100 kilometres an hour. And they're asking, how long does it take her to travel this journey? There's our question. So now we have to choose an equation. We're using the speed equation. The reason why we know that this is a speed equation question is because there is no acceleration in the question. But we have to ask ourselves, which one of the equations is the best one for us to use? Now, because we've listed our givens, we can see we've got the distance travelled, displacement. We've got the speed, but we don't have the time. We want to find the time. This version of the speed equation over here puts time all by itself on the left-hand side of the equation. That's the one we want to use. So we declare our equation, T equals S over V equals 150 kilometres. Now I'm going to put the units in here because we're not dealing with metres and seconds this time. So I'll put them in just to remind myself that I'm dealing with kilometres, and I'm also dealing with kilometres per hour. We end up with 150 divided by 100 is 1.5 hours. And you might be asking yourself, how did we get hours after that? Well, we had kilometres divided by kilometres per hour. The kilometres cancel each other out, which leaves us with 1 divided by 1 over hours, which means hours. So we've declared our givens, we've chosen an equation, we've shown our working, we've given the answer, and we've given our units. Another example. Dion swims 200 metres in 2 minutes and 40 seconds. 200 metres, 2 minutes and 40 seconds. How fast is he swimming? Okay, so the distance that he's travelled, S equals 200 metres. The time that he takes to do this, 2 minutes and 40 seconds. 2 minutes is 120 seconds, so 2 minutes and 40 seconds is 160 seconds. And they're asking us, how fast is he swimming? That's the big question mark. So we're back to the original version of the speed equation, because we want how fast is he moving, and that middle version of the speed equation has the speed on the left-hand side all by itself on the equation. So we declare our equation, F equals S over T. We show our working, 200 metres over 160 seconds. And we give our answer 1.25 metres per second. We've read the question carefully, we've listed our givens, we've declared our equation, we've shown our working, we've given our answer, and we haven't forgotten the units. Two to go. Elizabeth runs at 2 metres per second. How long will it take her to run 300 metres? So we're looking for time again. We list our givens. V equals 2 metres per second. It's just a casual jog. The distance is 300 metres. And the question asks, how long will it take her? So we might go back to that version of the speed equation where time is all by itself on the left-hand side of the equation. T equals S on V for this one. So T equals S over V. We declare our equation. We show our working, 300, over our speed, which is 2, and we give our answer 150 seconds. We have shown our givens, declared our equation, shown our working, given our answer, and not forgotten the units. Last question. Frank rode his bike for 2 minutes. If his speed is 12 metres a second, how far does he go? Okay, so it's a speed equation. There's no reference to acceleration, so it has to be speed. We look at the givens that we have. What do we have? 2 minutes, time. Time equals 2 minutes. We might turn that into seconds. 120 seconds. Speed is 12 metres a second. How far does he get? Distance is the question. So now we have to choose which equation do we want to use. We're looking for how far he goes, the distance. When we look at the different versions of our speed equation, the one on the left here has distance, that's S, on the left-hand side of the equation all by itself. So that's the one we're going to use, S equals VT. S equals VT. Show our working, we've got 12 multiplied by 120. And we give our answer 1,440 metres, which by itself is perfectly fine and correct and will get you full marks, but you might want to change it into something that's more common, like 1.44 kilometres. Givens, equation, working, answer, units. That's the end of this video. In this video, we were trying to look at good habits for speed calculations. And those good habits are: read the question carefully, list any values you've been given, show equations, show the equation you've chosen, show all your working, give your answer with units. This video has not covered how to choose the right equation or how to manipulate equations. And this video has not covered how to choose good units. This video is just focused on good habits for the calculations. Those other skills will come with time and practice, and hopefully some more videos.